Hello, my name is Andrew Huntress, and in this video I would like to show you a game that I have been developing called Quarkle. First of all, I made these cards on a website called thegamecrafter.com. You can just use a simple kind of Photoshop program and you can make cards that really look like nice. They're made on actual card stock, like real playing cards, and you can make and develop your own game to use. I've found as a teacher of math and science that it can really make a difference with students when you have real legitimate looking cards that you've developed. You've put the time in to make it a fun, interesting game, and you can even sell it to other people around the world. I've already sold about 75 copies of this around the world. I don't really make any money on them. It's just basically selling them at cost. But it's nice to know that there are many different teachers that are benefiting from the work that I've put in all around the world, in being able to get students to have fun and be excited about particle physics. And hopefully some of those students go into particle physics. We could have the next Niels Bohr playing this game in high school and then getting interested in it and solving the big ideas. So I think it's really interesting. I think it was fun to make this game, and I'd like to show you how this works and how to play it. So you'll notice right away that the game comes with two types of cards. There are matter cards, of which you'll get the 6 different types of quarks. In the upper corner there is the charge, that's the electrical charge on the quark, and you also have a box with different colors here, that's the color charge, and you'll have the name of the quark. And again, those are repeated in the bottom corner so that when you're holding the card you can see it. Whether you're holding it upside down by accident, you can still make out what those things are. Now, for the initial gameplay, you're not going to want to use the color charge. That would really be for a more advanced setup. A little bit later, once students have learned quite a bit about things to advance the level, I start using the color charge to make it interesting again, and you can start playing it all over again at a new level. But we have matter cards and we have antimatter cards. And so you'll see that this is anti-up versus being up. And the students will notice right away that the charges are going to be opposite on an up quark and an anti-up quark. And that way you don't even need to tell them that that's happening. They'll notice as they look at the cards, they'll see an anti-charm has negative 2/3. Automatically a charm quark will have positive 2/3. And all of those charges are, of course, in elementary charge units. So we have up quarks, down, charm, top, bottom, strange, all of the different types of quarks, and the corresponding anti-quark cards. All right, so there's only 2 rules to this game. Now, of course, you'd normally have these shuffled very nicely to play the game. I have them separated out right now just to show things a little more quickly. But the 2 rules to this game that are most important are you can only make particles out of either 3 cards or 2 cards. That's the first rule. 3 cards or 2 cards to build a particle. And the second rule is the rule of conservation of charge, which means the charge of a particle has to happen in integer values. So, for instance, I could take these 3 cards and say that the charge in the upper corner there adds up to 6/3, which is positive 2 elementary charges total. So that's an up, up, up. That makes a particle. That particle would be called a baryon, and students would start to learn very quickly the different vocabulary words of particle physics that makes a baryon. I could also make an anti-baryon pretty quickly if I take some, let's see here, let's take some cards like this, and I have an anti-baryon. Notice that anti-strange, anti-down, anti-bottom, that will add up to positive 3/3, which is positive 1. Again, conservation of charge. We have positive 1 charge, and there's our anti-baryon. And I could also make a meson by taking some cards, an up and an anti-down. Together that adds up to positive 1. And we have a meson particle. So remember, 2 cards or 3 cards to make a particle. The other thing that can happen is sometimes, depending on how students will pick what they make, let's say that I had an up and an anti-up. Notice that those are exactly antiparticle of one another, and so that's actually not going to make a meson. That is going to make an annihilation. That will be a huge explosion of energy. The mass here of both quarks would be converted into energy. So we call that an annihilation. So we can have an annihilation, a baryon, an anti-baryon, or a meson over there. Now, all that I've really told you so far is how to make particles or annihilations, not really how to go through and play the game. And whenever I do this game with people that have not played before, I like to show them first how to make the different types of particles, the names of the particles, and just get a very quick idea. Now, we're not using the color charge in the corner there yet. You notice we have red, blue, and green on the quarks, and we have pink, cyan, and yellow on the anti-quarks. We're not using those yet. That's for more advanced play. But let me shuffle these up, and then I'll show you how this game runs. All right, so I'm going to show you how to play a 2-player game of Quarkle, and you can play with up to 4 players. There are enough cards in one deck to play with up to 4 players. You could play with more, but the game ends up being quite quick if you play with more than 4 players. So the idea is going to be to get rid of all the cards in my deck here as quickly as I can by making particles, antiparticles, and annihilations. So here's how the game works. Each of the players is going to put 3 cards down in front of them, and those are the cards that they can use to build particles and annihilations. So I'm doing this with 2 players, so I'm really only going to be using the cards on this side to show, but just so that you see the setup of playing with 2 players, you can imagine there's another person across from me playing. Now, my goal is to get rid of all of these cards by making particles and annihilations. So I'll start out pretty slowly here, and I want this to be very accessible to students that don't know anything yet about particle physics. So it's just going to be about adding the charges together in the top corner. My goal here is to make particles or annihilations where it is an integer charge when I add the charges up. So here's how the game begins. At the beginning, everyone who's playing is going to say Quarkle and put 1 card here in the middle. Now those cards are for everyone to use. And the way that we can do this is I'm going to try to make particles as quickly as I can. So maybe, and I have to use at least 1 card from this middle area and at least 1 card from my own area. So maybe the first thing that I would do is make a baryon by taking all of these cards, and you can add those up. You see that it adds up to a positive 1 charge. And so up, up, down, actually, interestingly enough, that makes a proton. But in general, we would call this a baryon. So I say, I made a baryon, and I put that over to the side in my particle pile. So we're going to count the quarks that we've used up at the end of the round, and we'll see who has used the most quarks will have a score for the end of the round. Now, before I move on, as quickly as I can, I need to replace the middle card first, and then I replace the cards in my row to continue building. And now, once I've replaced the cards both in the middle and on my side, I can continue to make particles and annihilations. So perhaps I'll make a up and an anti-top here. You see how these cards add together to be 0 or neutrally charged. So that would make a meson being that I've done 2 cards makes a meson. And again, we'll replace the middle and then replace my side here. So to speed things up, if we keep going, we could make another baryon right there. It adds up to an integer charge. And we'll replace all of the cards. Now, what you might be thinking here is, I'm just playing as one person. I don't seem to be taking any turns. And the fun part about this game is you're not actually going to take turns. Everyone goes at their speed, so it can be a very fun blitz style game where both people or 4 people are all interacting with the cards and making these particles and antiparticles and even annihilations very quickly. So you might notice on the board here I have a strange and an anti-strange, and I can put those together and have an annihilation. So if I continue to make cards pretty quickly, we could say, all right, I've made an anti-baryon there. And as students get used to this, it will speed up rather quickly. They could make another meson, and you can start to see how students would get very competitive in building their particles. And they start to think of ways that they could do this more and more quickly, ways that they start to see patterns emerge in what's going on. And so I make another anti-baryon. And it's really good to have the students say the vocabulary words as they're doing the game, because they think that they're just playing a game, and in the game it's called a baryon, but really that's vocabulary that we want the students to know. So as I keep going here, and I could play this, for a long time and make another meson, but you get the idea of how this works. The important thing is that you replace that middle card first so that other people can continue to play and you can't stall the other people. So I'm trying to run out of cards over here to finish up the game. Of course, I'm not playing against anyone over there on the other side, so I've got this big pile of quarks on my side of particles that I've already made. And at the end of the game, at the end of the round, we'll just count up how many quarks we've used, and that's my score for the end of the round. Now, there are a few other layers to this game. It's a fun game to just play quickly and add fractions together quicker than your opponent, to build as many particles, to gather as many quarks to your side as you can. But the more interesting thing I think about this game is really the science that goes along with it. You can make a hypothesis about how these quarks go together into these different types of particles, antiparticles, and annihilations, and you might start to notice patterns. You should start to notice patterns, and then you can set out to run experiments using the cards and look at the different combinations of what's possible and look at the different things that will not work. And as a hint, what if we looked at 2 antimatter cards and 1 matter card? These fractions do not add up to an integer, but when I look at these 3 matter cards, it does add up to an integer. And when I look at these 3 antimatter cards, it does add up to an integer. And you can start to make a hypothesis about what's happening with matter cards and antimatter cards in pairs of 3. You also might notice what happens when you just try to put 2 cards together of certain types. Do you get a particle that obeys the quantization of charge or not? So that's another layer that I like to move the students into, and usually students naturally will notice this after playing the game a few times. They want to play the game faster, and so they want to make a hypothesis about something that they can then figure out to see deeper into the structure of how these particles really work. The kids start to get very interested in how that works. Now, the last layer of what's going on here is, you may have noticed, you probably noticed, I have not been using the little colors that are in the corners here. I called that the color charge back at the beginning, and you may have noticed we have not been really doing anything in reference to those. So the way that color charge works is I like to save this until after students have really done quite a few different hypotheses and different experiments run with the cards, and they've really looked through how to play the game very, very quickly by noticing patterns and structure that underlies what's happening. Once they've gotten to that level and they're just before they begin to feel like the game is lacking in complexity and starts to get too easy going through, you can add this last layer of the color charge. And so to make an anti-baryon like this, there are 3 different color charges that these possible quarks can have. And instead of only having the numbers add up to an integer, you can also start to require, which actually does happen in nature, that the color of the 3 anti-quarks be different. And so this would actually make an anti-baryon, whereas this would not make an anti-baryon because the colors don't work out. I need to have one of each of the 3 different colors to make it work. So if I look at the matter cards, if I take matter cards into consideration here, notice there are 3 different colors of matter. There's blue, red, and green. And together, since all 3 of those are different, that makes a baryon. But if I were to try to do this, it would not make a baryon because I don't have that green color that I need for a baryon to be made. And the last layer of this color charge idea is when you look at the mesons. If I try to build a meson, the colors actually have to be opposite of each other. So I could make a meson, if I get some cards out here to get all of my options together. If I had, I would need blue and yellow together to make this meson. And the way that this works is actually you call it blue and anti-blue. Yellow is, in this way of looking at things, yellow is the opposite of blue. I could also do an option of perhaps green and pink, pink being the anti-green color, or I could do red and cyan. So the cyan color, which on this video looks a little bit blue, but it's actually cyan. If you look in a little bit better light, you can see the lightness of that blue color. So this is red and cyan are also going to be anti-colors of each other. So this would be the top level of playing this game in requiring that. I usually don't require that at first because you want students to make hypotheses about the charges and then set out to really look at all the different combinations of what can happen, learn some things about the underlying structure of what's happening with these baryons, anti-baryons, mesons, and annihilations. And then once they get to that level, you can add in this color charge to really up the level again. It makes it much more active thinking about how they can build particles. It slows the game back down again and makes it interesting all over again. So I've found that I've taught students how to play this all the way down to 8 years old. One of my sons loves to play this game at only 8 years old because it makes particles very accessible to students. So, last but not least, I have made this game available. If you'd like to purchase a copy, you can get it at thegamecrafter.com. Just search on that website for Quarkle, spelled just like that, and you can get a copy. I don't really make money on this. I'm not looking to make money, but I am looking for other people to be able to use a good resource to get cards instead of trying to print out a bunch of cards and take all that time to make them yourself. You can just buy a pack and it's ready to use with your students. I think it's a great activity. So let me know in the comments below if you have used this or if you're interested in using it, and I would love to talk to you about it.